Now let's look at these points. First one is kappa of kn is nothing but connectivity of a complete graph with n vertices, that is equal to n minus 1, that is equal to delta of g. So in this case delta of g is nothing but minimum degree. Minimum degree is equal to maximum degree in case of a complete graph, which is equal to n minus 1. Now as we know, according to the definition of the connectivity, the graph, whenever I delete some vertex cut, the graph should get disconnected, which means I should be able to get more than one component, or only one isolated vertex should remain. Then only such a vertex set is called as vertex cut. Got it? So now according to this definition, in a complete graph, so let us say I'll take an example. This is K4, complete graph with 4 vertices, right? Now in this case, if you want to isolate the graph, it will never be possible to produce 2 components. The reason is, whenever I try to delete a vertex, let us say if I delete this vertex, then what will be remaining is a triangle, which is nothing but K3. If I try to delete this, what will be remaining will be an edge, which is nothing but K2. If I try to delete this vertex, what will be remaining is a single isolated vertex, and this is the only way we could get the connectivity, right? Or according to the definition of connectedness, so this is the only way we can say that the graph is disconnected according to the definition of connectivity, right? So now let's take K5 once. Now in this case, if we delete one element from K5, I will be getting K4, and again the process remains the same. So in case of complete graphs, you will never be able to get 2 components, right? So only way is you can go till one isolated vertex, and the number of vertices required to be removed in order to get to that state is nothing but the connectivity in this case. Okay, now connectivity of Kn is equal to n minus 1 according to the definition. Okay, fine. And next one is kappa of g, which means connectivity of any graph in general, should be less than or equal to number of vertices in that graph minus 2, where g is not a complete graph. So how to see this is, so what they are trying to say is, in order to disconnect a graph which is not complete, in worst case you might have to delete these many vertices and no more. So by deleting these many vertices, you should be able to disconnect any graph, right? So let's take a worst case graph. For this explanation, the worst case graph would be a complete graph in which we remove just one edge to make it non-complete. Okay, why? Because they are saying that it should not be complete. Okay, I am trying to explain this. If you are not able to understand it, don't worry, leave it. Just try to remember this, otherwise try to follow it. It is not that easy to follow. Now what I am trying to say is, in order to prove this point, we should assume a graph which is not complete. Now what is a non-complete graph? There should at least be one vertex in the graph which is not adjacent to all the remaining vertices, right? Which means there should at least be 2 vertices in the graph which are not adjacent to each other. Then only it is called as a then only that graph is not a complete graph. Are you getting this? Again, there should at least be 2 vertices which are not adjacent to each other. Otherwise what happens? It will become a complete graph. Now let us take such a graph, which means there are exactly 2 vertices. There are at least 2 vertices which are not adjacent to each other. Now what I will do is, I will remove all the other vertices other than these 2 vertices. Then what will remain? Only these 2 vertices will remain, and they will be disconnected because initially they were not connected. Therefore, in worst case, right, you might have to remove these many vertices in order to disconnect that graph, right? And you need not go beyond this in order to disconnect a graph which is not complete. Are you getting this? If you want to see it in terms of diagram, let us say there are 2 vertices in the graph. These 2 are not connected, but then all the entire remaining graph is completely connected. Let us say there are many vertices here and everything is completely connected, and all of these are connected to these 2 as well. Now what I can do is, I'll just remove all these vertices. How many vertices will be there? N minus 2. I'll remove all these vertices, then only 2 vertices will remain which are not connected to each other, and so I got 2 components, and I can say that this is the vertex cut. Therefore, your vertex cut need not go beyond that. So in worst case, your vertex cut can be this thing, right? Okay. And now the next one is the hypercube QK for k is greater than or equal to 2. In a hypercube QK, for k is greater than or equal to 2, let us say in a hypercube QK for k is greater than or equal to 2, the neighbors of one vertex in QK form a separating set. So kappa of QK is less than or equal to k. So what is the meaning of this one is, in worst case, if you want to isolate one vertex from the remaining vertices, what you could do is take one vertex and remove all the vertices adjacent to it. Then what happens is that vertex will remain in one component and all the remaining vertices will remain in the other component, right? Therefore, in worst case, you need not go beyond the number of neighbors that a vertex have. In best case, you might be able to do better, but then that is not what we are interested in, right? So you need not go beyond this. That is what we wanted to prove. Got it? So what I mean to say is, let us say this is a hypercube. Now in this hypercube, every vertex is adjacent to 3 other vertices. Now you take any vertex and you try to remove all its neighbors. Then what will happen? That particular vertex will be isolated and all the remaining vertices will be in some other component, right? Therefore you are able to get 2 components by deleting k vertices. Therefore kappa is always less than or equal to k, which means you need not go beyond that, and in best case you might be able to do it with less than that, but I am not interested in that. I just want to know the worst case number, right? In worst case you need not go beyond that. Okay. And now deleting the neighbors of a vertex disconnects a graph. So kappa of g will always be less than or equal to small delta of g. So what I mean by this is, if you have a graph, right, then in order to disconnect that graph, in simple case what you can do is take a vertex which is having the least degree. Least degree means which is having least number of neighbors. Then I'll remove all those neighbors. Let us say this is all the graph, okay, and we have all the graph here. Now let us say this is the graph, this is the vertex with least number of neighbors. Now I'll remove these 3 neighbors and I can guarantee you that this vertex will get isolated and all the remaining vertices will be there. Therefore I can get at least 2 components in this way. So in worst case, I need not delete more than this number of vertices in order to disconnect a graph. So our kappa will never be beyond that. Got it? Okay. Now one more point is there. Kappa of the bipartite graph k m comma n is minimum of m comma n. So which means if you have a complete bipartite graph k m comma n, what is complete bipartite graph? Every vertex here is connected to every other vertex in the other set. Okay. Now in order to disconnect all the or in order to create components, you are supposed to delete either this set completely or this set completely. Otherwise what happens is, even if you let one vertex stay here and one vertex stay here, they will still be connected. As long as you have one vertex here and one vertex here, you will never be able to get components, right? Let us say you deleted this vertex. What happens? All the remaining vertices will be connected through this vertex, right? Let us say you have deleted this vertex. What happens? All the vertices will be connected through these 2 vertices and this vertex, right? So by deleting all the vertices of one side, then only you will be able to disconnect the graph, right? Now which side is it better to disconnect? Better take the smaller one. Why? We are talking about the kappa, right? So kappa is equal to minimum. You can either delete all of these from this side or all the vertices from this side and you can disconnect it. Now since we are talking about kappa, which is nothing but the minimum, you are supposed to take the minimum of these 2 sets. That is why minimum of m comma n. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs universities better than IITs. They have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay, IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.